Okay, hi, Danny. I'm very happy to interview today Danny Weitzner, who is a longtime friend and colleague at MIT. And Danny is a principal researcher in the CSAIL laboratory and also the head of the Internet Policy Initiative at MIT and CSAIL and many other affiliations, which makes him the perfect colleague to also be on our duality advisory board and the world expert on cryptography, policy, issues that have to do with government, law, security, cryptography, and privacy. And I think we're in a very interesting time in this respect in the world. And let's start our conversation. So first of all, I wanted to ask you, Danny, to tell a little bit about yourself and about your background.
So I have a checkered past. I studied philosophy in college. That was not very marketable. So I then spent 4 years doing technical work, working with a combination of small, rich investment banks and poor nonprofits in New York City. I also had the distinction of having installed what I think was the first token ring network in sub-Saharan Africa, connected with a World Bank project. So I have a technical background, but I always felt like there were these critical questions in computing and policy. So I went to law school, and I didn't really know where that would take me, but where it took me was to the very beginning of what I think of as the internet revolution. So I arrived in Washington in 1992. I was the first lawyer in Washington, D.C. for the Electronic Frontier Foundation. And we worked on this whole fascinating range of issues: First Amendment issues, free speech on the internet, surveillance, how would the Fourth Amendment apply on the internet, and a whole bunch of other legal issues. And that's really where I first met a whole number of really leaders in the cryptography community: Whit Diffie, Ron Rivest, all kinds of wonderful colleagues. And we had to very quickly figure out this set of questions about surveillance and encryption, because of course the FBI and the NSA were very worried about what would happen if there was what we now call, I suppose, end-to-end encryption. And they said there should be this thing called key escrow, where someone else would hold keys. You remember all that. And that was a kind of a sort of honeymoon period, I think, of internet policy, because it was all upside. Everything was very exciting. The internet was growing really rapidly. It created these extraordinary opportunities for people to have access to information, to speak. And there also seemed to be a lot of exciting privacy opportunities. We had these very strong privacy technologies that appeared to be able to do a great job of protecting people's private communication against all kinds of threats. One thing led to another. I helped start a group called the Center for Democracy and Technology. Both EFF and CDT remain really important advocacy organizations. But in 1998, I had this naive feeling that we had done everything that was interesting about internet policy. So I came up to MIT to help Tim Berners-Lee set up the World Wide Web Consortium and worked on a whole number of private policy-related technical design questions in the web, privacy, security standards, a bunch of other things. And had a little stint working in the White House. I was deputy CTO for internet policy, where I mostly worked on consumer privacy issues. There were a lot of difficult questions about just the global internet, which had by that time gone from a kind of a exciting thing in the Silicon Valley garage to something that the whole world depended on. But governments hadn't really figured out how to be serious about the internet and internet policy. And after that, I came back to MIT, started the Internet Policy Research Initiative. And the final thing I'll say is that I think that in looking back at what has changed about internet policy and technology and computer science, I think that particularly in the area of security and cryptography, there was always a sense that what was interesting was what could be provably secure, what properties you could guarantee with mathematical certainty. And I think that's kind of come headlong into a more challenging, nuanced set of questions about how to actually evaluate the risk and manage risk of using information technology. Because what we know now is nothing's perfect. And the systems that we put out in the world have a lot of complexity to them, a lot of nuance to them. And we want to be able to manage risk in those systems because we depend on them as a society. But we're not going to get perfection, but neither do we want to just settle for the best effort. So I think, to me, the really interesting challenge in the maturation of a lot of these technologies is that we now have to treat them as essential, but also those that are subject to some risk, and where the goal, the intersection between technology and policy, I think in many ways is about being able to characterize and manage those risk levels so that we can do the things we need to do with the information we have without incurring risks that we think are not acceptable.
It's an age-old problem, right? Do you strive for perfection, or do you just do a good enough job? However,
Yes.
my own opinion is, in cryptography, it's a very risky thing to do a good enough job because we never know what the guarantees are. If somebody's attacking me and I'm unaware of it, in some sense, it's not that having a fast enough algorithm, but being secure enough only will be judged if it gets attacked or doesn't get attacked.
Right.
So, somehow having some standard to strive for, it probably is more important in the field of cryptography than in other fields that have only to do with performance. But cryptography really has to do with guarantees, or in advance guarantees. But we know this, we can debate this.
Yes. Yes.
I want to touch on a different topic that what you say raised, and that is saying we wanted security to do what we need to do. What is it that you think is the potential? Let's say maybe it has to do with collaboration, maybe it has to do with computation in the cloud, maybe it has to do with making sure that our civil liberties are maintained.
Yeah.
What is the potential of privacy enhancing technologies? Is it just making sure that we're safe in doing what we were doing all along, or is there some new things, brave new world that we could?
Yeah. So it's such a good question. And I think that in a lot of ways, what has matured are kind of computing and networking capabilities. That is, if you want to get information from one place to another in the world, wherever you are, almost, you can do it. You want really fast computing for most imaginable computations, you can get it. You can get it reliably, and it's generally cheaper and cheaper as time goes on. So those are good. What is harder is data. So the data that actually feeds that computation, I think we're discovering, is a much more complex set of properties. And we know we have more and more data. We have, whether it's data about people's health or data about transportation or financial data, you name it, data that might help detect terrorism. There's so much information out in the world. And I actually think we are mostly underutilizing it. There's mostly, I think there's this huge sort of surplus of potential knowledge out there for which computer science has a lot of the tools to conduct analysis, but we have a hard time, for a lot of reasons, getting that data in the right place, in the right people's hands to contribute to the analysis that we need, whether it's how do you make roads safer, or how do you develop new drugs, or how do you figure out, just exactly what kind of healthcare a particular person needs based on commonalities they may have with others who they may share similar properties with, but those people may be spread widely around the world. So what we know is we want to reach into lots of this data, but we're worried about how to manage the risk, both of just the underlying security of that data, but also the potential abuse of that data. We focused a lot in the privacy debate on things like the surveillance economy. Does Google know too much about us? Does Amazon know too much about us? Facebook? Probably they do. But I think what's really interesting is all the institutions that have huge amounts of valuable data about us that we can't get at. So we don't know enough about ourselves is, I actually think, the interesting privacy problem. We don't know enough about our society to be able to make well-informed decisions. And that's where I think, back to your question of what kinds of guarantees can we get from, different kinds of computational environments, from different kind of analytic environments. We generally, I think, are over-indexing on the privacy risks because we don't have a way to measure them or manage them in a way that's reliable. Again, I think I don't want to say we've solved all the communications and computation problems, because there's always more work to do, but those are mature. But I think our interaction with data is actually quite immature, and there's a huge amount of growth to be realized there.
So to summarize, is that the potential of the privacy enhancing technology, like fully homomorphic encryption or multi-party computation, or things beyond just communicating securely, is in harvesting data while adhering to some rules which we haven't defined yet. So these days, there's a lot of interest in the last few weeks, actually, in sort of policy, and regulation for this type of technology. And I guess I was hoping you could talk about that. First question is, why is there so much interest all of a sudden? Both, I think there's a federal bill that's coming, proposed, and it's bipartisan. There's also some UK, USA interest in some sort of challenge for cybersecurity. And nobody better than you to tell us what's going on. Where do you think it's going?
It's a quite exciting time, I think, in privacy and security regulation. We do have in the US, as you said, a new bipartisan privacy bill that's working its way through Congress. And why is that happening? I think it's happening partly because the public, the citizens, are just getting increasingly nervous about who has their data and what's being done with it. And, there's been high profile cases where you see abuses from Facebook, from Twitter, from others. There's also the fact that I think while the US really led on internet policy questions for the first couple of decades, we're now, if you're kind of keeping score, behind. So Europe passed this very broad general data protection directive, which is a really kind of state-of-the-art privacy law. And I think the US is now feeling like, well, maybe we better get our act together as well. I think one of the great things that's happened as a result of both the GDPR passing and the consideration of the US law is that it's really, I think, encouraged the computer science community and companies that are developing computing products and services to look more carefully at the privacy arena. So as an example, both in the European law and in the new proposed US law, if you can say that you're not releasing personal data, you actually get out of a lot of the requirements, or you may get out of a lot of the requirements of the law. So for example, if there's a way to put together the right combination of multi-party computation protocols and homomorphic encryption algorithms, maybe that gives companies more leeway to perform more analysis on data without all of the regulatory restrictions. So I think that now, is that going to happen or not? That's going to really depend, I think, on a careful dialogue between the technical community and the regulatory communities around the world. Right now, again, there are a lot of socially positive computing activities that don't happen because of worries about privacy risk. As an example, financial fraud that probably isn't detected because the companies that might do that detection are nervous about whether they can use the personal data they have for that kind of fraud prevention. We talked about health information. Hospitals, other organizations that have health information are sitting on a lot of knowledge, partly because they're nervous about whether making it available to researchers will open them up to privacy liability. So these privacy laws that are either in place or being passed, I think, create the opportunity to have really focused discussions about exactly how we can use data for these purposes that everyone's going to recognize as positive, but do so in a way that conform with the rules. Because as you said, the problem we have had in a lot of cases and still have with privacy is kind of a general quality. It's a general feeling, but it's hard to know exactly when a particular computation, a particular use of data is or is not consistent with privacy rules. As the laws get more clear, I think the technology will also be able to get more clear. And in the middle of that process, we'll have, I hope, a lot more innovation, a lot more scientific advance, and ultimately a lot more useful knowledge.
So in particular, this bill that's being passed, is it like an American version of GDPR or what?
It has a lot of features in common with GDPR. It has a lot of the same broad rights, rights like you have a right not to have your data only used consistent with the purposes that it was collected. You have your right to have the data held securely. You have a right to access your data, to correct it, to delete it, all those kinds of things. So the broad rights are pretty similar. The mechanisms are different just because the US legal and regulatory system is different. And of course, the big difference probably is that the GDPR is, as its title says, a general data protection law. That is, it covers essentially all uses of personal data with a very few exceptions. The law that's being considered in the US would be one of many federal and state privacy laws. So we already have privacy laws on financial privacy, on health information privacy, and many others, privacy of tax records, of voting records, all those kinds of things. The US landscape is always going to be a little bit more complex, but I actually think that's a good thing, because what it does is it allows, for example, if we want to really get into details about how could you get better research access to health data, you can go to the Department of Health and Human Services and say, let's really talk about how HIPAA, the US healthcare law, applies here. So I happen to like what people call this sectoral model of privacy rules. What the new law that the US is considering does is it fills in this big gap in kind of the area of general commercial activity, not all the social media companies, but also, retail companies, just all the different organizations that consumers interact with that aren't covered by one of those particular laws. So maybe it'll pass this year, maybe it'll pass a little later, but sooner or later we'll have some law in that space.
So this is sort of a more general question relating to policy. Whenever you hear a talk about trying to motivate, to a general audience at least, the whole question of security, cryptography, privacy, often people will quote the right to be left alone, which is attributed to Judge Brandeis. Yeah. In these days, I guess I was reading one article here in preparation for our interview. There's another quote saying privacy rights are civil rights. These are slogans. They're not really grounded in law, right? I mean, and one thought that comes to my mind is how far does that go? So yeah. What is it based on? And second of all, another thing comes to mind is it just that what I say should be private, should not be found out? Is it my data that should be secret? Can I go into another extreme? Should I be able to deny things after the fact? So say I'm doing computation using FHE or some other form in the cloud. And then somebody comes to me and says they subpoena me, or maybe they threaten me, and they say, show me all your work. There is some public record of it, maybe. Right. We have ways now to actually deny that. We have encryption schemes where we could sort of convince them that we did one thing, whereas the truth is we did something completely different. And that, of course, goes into this fake reality thing, but it also is something about our right to use.
Yeah.
Any thoughts?
Well, let me start with this question of privacy rights as civil rights, which I think is really interesting and quite relevant. One of the things that has actually enlivened interest in privacy protection in the US is actually the discussion about race and policing and the racially and ethnically based discrimination that I think we're paying more attention to as a society. So actually, in this new privacy bill that's being debated in Congress now, there are specific rights having to do with assuring that, for example, individuals are not subject to algorithmic decision-making based on race, gender, or other protected categories. We already have, of course, laws on the books that say, for example, you can't be subject, if you're applying for a loan or applying for a job, you can't be subject to discriminatory decision-making. The challenge now is we have these very complex computational techniques for categorizing people and predicting whether they'd be a good employee, not, or a good credit risk or not. And we now have to figure out how to really seriously ask the question, are those techniques discriminatory in some way in violation of these rules? You know of all the work that's going on fairness. They're pretty complicated questions, but there's a reconnection of these questions of discrimination on the one hand and privacy on the other hand, and a recognition, for example, in the case of surveillance, that a lot of the targets of surveillance tend to be people who are racial or ethnic groups that are categorically mistreated. They're subject to more police attention, and so the way that we construct surveillance laws has disproportionate effect on people who are more subject to police attention. And the same thing with any other kind of law that involves the use of personal data. We know that a lot of the decision-making algorithms are based on biased training sets to begin with. That means that the bias that we have in society carries over. And of course, the mechanism through which it carries over is the use of personal data. So that's the sense in which privacy really is a civil rights issue, because it's either a basis on which we're treated fairly or unfairly. The vector is the personal data, one way or the other. You know, your question about surveillance and deniability is really interesting. People who come into the US who go through immigration processes now often have to submit their social media identities. I think it's a really horrible practice. I mean, it's one thing to say, well, you know, if you're coming into the country and you have a criminal record in some other country, then I understand why immigration authorities might want to pay attention to that. But to just be scrutinizing people's opinions, people's exercise of their free expression rights online as a basis for assessing immigration, I think is really a bridge too far. Whether it's a specific constitutional violation in the US is sort of a little more complicated because of people's immigrant status, but clearly, or citizenship status, but clearly it's a violation of human rights norms to do that, in my opinion. So yeah, I think that privacy, because so much of our interaction with the world is through the vehicle of our data, privacy becomes this almost universal rights litmus test, right? How our personal data is used really is a reflection of how we're treated as individuals, period. So it's become a much bigger question.
Perfect. That's where I actually leads me to my last question. You've been very generous with your time. Is so under the understanding, which is why I have decided to also try to commercialize some of the technology that's been developing for so many years, that we can, at some situations where it seems paradoxical, but we can actually derive utility without compromising privacy. What do you think needs to happen to accelerate adoption of these type of technologies? Is it scientific? Is it standardization? Is it just increasing the comfort and trust of people in these fairly advanced things? To us, seem of FHE. You can encrypt, you can compute and you get the result. That's like, I guess, what duality does. MPC, multiple people can exchange messages, and at the end they get what they want. They never revealed anything about their data.
Right.
How do you see it?
So I think clearly these kinds of secure computing technologies have this very important privacy, I'll call it a privacy managing role. That is,
Say for our audience that, when we say the word privacy, some people immediately think differential privacy. What I think it's cryptography. So computing things on data without, except for the result.
yes, right. So it allows us to understand where we have risk and where we don't, and when we can manage it and when we can't. So I think, to me, the first part of the process has happened thanks to your research and the research of others. Like, we understand the basic science and math behind the techniques. I think that we're in this interesting second stage now, where what is happening is people are gradually seeing that there's benefit from these approaches, that there's a practical way to realize benefit. And so it's one thing to kind of know in abstract terms what these kinds of tools can do. It's another thing to see, oh, there's a really concrete benefit. There's we reduced fraud risk in a financial transaction. We know more about cybersecurity. We know more about health factors, whatever it is. I think that, more and more practical examples, actual implementations, are going to help more and more people realize that there's a benefit. And in some sense, that's what policymakers need to see. Because I think the next step after this sort of piloting, the next step is to provide confidence to, I'll say, more institutionally cautious users that it's safe to do this. And where's that going to come from? It's going to come from actually a kind of a risk balancing that says, oh, I can get some benefit from it. That's why the pilots are important. And also, I'm not going to get in trouble for doing it. And for a lot of companies that have the kind of data that we're talking about, they have regulatory obligations, they have legal risk. They need to know that risk benefit equation comes out positively for them. And I think that's where governments, different regulatory agencies, have a really important role to play, to say, if you use this kind of technology in this kind of setting, we will consider you to have been appropriately careful, appropriately compliant with respect to whatever the privacy and security rules are for that data. Ultimately, that kind of assurance, I think, has to come from governments in the same way as this kind of general regulatory category called safe harbors. As an example, people who use health data for today know that if they remove certain data categories from health data, from patient health information, that data will no longer be subject to HIPAA rules or penalties. So we need, and that's just one example of a kind of a certainty that government can provide, that can say, if you do X, Y, and Z, we're not going to worry about you. You're going to be considered to have satisfied your obligations. What we don't want is a situation where commercial users, government users say, well, let's try it and see if anyone complains. That's not going to be a good approach. That's not going to scale well. We need more pilots to illustrate benefit, concrete benefit, and we need government action to encourage usage and reduce the risk. I'll give you one example of where this happened very effectively in the past. In around 2010, when the cloud computing industry was first getting started, there was a lot of uncertainty about this idea of handing all your code and all your data over to Google or Amazon or someone else and say, you do everything and we trust you. In the end, one of the things that made cloud computing more commercially viable was that the federal government set out a set of standards for procurement of cloud computing services, and basically said to federal agencies, said to the cloud computing providers, if you can meet, X, Y, and Z requirements, there were security requirements, there were cost requirements, there were availability requirements, then federal agencies can buy your service and use it, and have a kind of an easy path through the procurement process. that led to this explosion in use of cloud computing services, both in the federal government and outside the federal government. Because some central organization that was trusted and authoritative had looked at this particular set of technical offerings and say, yeah, if they meet these requirements, it's good to go. So we need that kind of thing, I think, over time in this area of secure computation, so that anyone who wants to use these services obviously has to decide they trust the vendor, but also has this extra layer of trust that someone else, some third party, has looked at it, and they're not going to get into legal trouble for doing it.
Fascinating. Wow, Danny, this has been really, there are a million thoughts going through my mind of projects that we should be doing together.
Yes, indeed. Yes, indeed.
Love talking to you. I'm so grateful. Thank you.
Thank you.